Good morning, afternoon, or evening, wherever you're watching from, and welcome to the live launch coverage of the Ariane 6 launching MTG-I2, L2, whatever it is, from the French Guiana and the Guyana Space Center. We're 18 minutes away now until the launch of the Ariane 62 rocket with the 2 booster variants. Now, this is the first ever, this was actually the first ever rocket to make it in the Ariane 6 program, as the Ariane 64 version came a little later. So, Ariane 62's first launch was around 2024. Now, this is a 2-stage rocket that can bring launches to low Earth orbit and geostationary transfer orbit, which is actually today's launch, and we'll be going to a geostationary transfer orbit. We'll talk about that a little later. So, and it has 2 strap-on boosters, as the name suggests, Ariane 62, while the Ariane 64 variant has 4 boosters. Now, about the payloads it can carry to orbit, it's pretty different from if you launch to lower orbit versus geostationary transfer orbit. For example, when you launch a satellite to low Earth orbit, you will have 10,900 kilograms and 5,100 kilograms if you launch from a geostationary transfer orbit. And this is the max kilograms, by the way. Now, today's payload, the MTG, I'm just going to call it L2 because I think that's the name, which is also called the Meteosat 14, is a next generation or a third generation follow-up to the Meteosat MSG series of geostationary satellites. Now, this satellite system will consist of a twin configuration of 3-axis stabilized satellites, which are the imaging mission satellite and the sounding mission satellite. Now, the imaging mission satellite is the MTG-I or L, and the sounding mission satellite is the MTG-S. Now, the payload proposed for the MTG-I consists of the flexible combined imager, or as we'll call the FCI, lightning imager, LI, data collection systems, DCS, and search and rescue, GUSAR. The FCI is expected to outperform MSG, spinning an enhanced visible and infrared imager, Severi, whatever, observations on clouds, aerosol, moisture, and fire by adding new channels in the solar domain and by improving temporal, spatial, and radiometric resolution. Now, this is all launching today. This is the function that a MSG satellite has for imaging. And the manufacturer of that satellite is OHB, which I have no idea what that stands for, and Thales Alenia Space. And the operator launching is EUMETSAT. Now, once again, today's launch will be going into a geostationary transfer orbit, and it is a singular payload that weighs about 3,760 kilograms. Now, we're less than 15 minutes away until the launch. Now, today's feed here is brought to you by the International Rocket Launcher, who has access to the clean feed here. So just shout out to him for the footage. And this is also since we couldn't get our own hands on the clean feed today, which is kind of odd, but it is what it is for today. Now, once again, the Ariane 62 rocket, made by ESA, launching by Ariane Space. I believe it's one of the only rockets they have active, which is very sad. I believe that's the only rocket they have active, since Vega C is now officially from Avio. It's no longer owned by Ariane Space, at least. Now we're coming up to 30 minutes 55 seconds until the launch. Everything is looking good here. It's a calm evening. It's very early evening. It's not even close to evening, actually. It's coming up to 5 p.m. local time. We can call it early evening in about an hour. Now, once again, for the people just joining us, you're looking at live coverage of the Ariane 6 launching MTG-I2 from France. Or as well, the Guyana Space Center in French Guiana. And that will be... Hold on just a second here. We apologize if you hear any background noise while I'm talking. That's the mic itself. Today I have a less of a better mic than what I usually have. And that's also because we're halfway somewhere else. And there's that weather that's being provided here from international rocket launches. You're currently seeing the weather. It is 17 kilometers wind, 17 kilometers per hour, cloud cover about 1%, and I can read that there, but it was about 4%. I don't know if you can hear me twice, by the way. I don't think so. If you can hear me twice, let me know. Okay. Maybe I should talk like this. Does it sound better then? I think so. Yeah, it does actually, but you're gonna have to deal with the bad quality because the mic is not as close as I want. So, we're about 11 minutes and 30 seconds off until the scheduled launch. And if any of you have any questions, please let them know in the chat. We will answer them to the best of our ability. At least my ability. And there you can see it's from the international rocket launches. Just a feed a little glitchy there for some odd reason. Just gonna refresh that. There we go. Should be fine now. Once again, launch feed from international rocket launches here. So we're using their feed for today. Now I'm gonna announce the server or that we're live as well, since I forgot to do that. If you're not already in the Discord server, you can head over to the bio on my channel, and there should be a link of the Discord server, and it will automatically make you a member, and you can be in the community. Also, it is MTG-I2. I just realized that. So big thanks for myself for figuring that out. And it makes sense too. There we go. That live stream is now posted on the official server, so everyone gets let know that we're 10 minutes off until the launch of an Ariane 6 rocket. Now, for today, we sadly do not have any clean feeds hosts, which I really look forward to, and it was really possible, because we have it ready, but I just forgot to make the stream, and I'm not going to make the stream now, because I don't have the ability to make thumbnails here. So, if I do, actually, I could make it, but yeah, I think we're too late now. So, we're just going to chill here. Of course, if you guys have any questions, and or you're just joining from the server here, I'm just having a little chat with some people. And if you're just joining in from the server, welcome to the stream. Today, the launch of the Ariane 6 rocket with MTG-I2. And glad that you're joining us today. It's, of course, very nice to see you here today. We are 8 minutes off, 8 minutes 25 seconds until the launch. And looking good. So we do have the mission control channels open, I believe. So if there are any callouts, we will hear them. Currently awaiting that launch of the MTG-I2 rocket in 7 minutes 25 seconds time. We could take a little listen in to the official coverage, but I don't think it's very necessary. People like clean feed a lot. Now this stream is not clean feed by itself, we're just using the clean feed that's being provided here from Ariane Space. They have a minute delay on their stream. That's absolutely insane. Like, that's way more than a minute. That's not okay. Six minutes, 20 seconds off. Now, once again, Ariane 6 will be launching the MTG-I2 satellites into a geostationary transfer orbit. So we're still awaiting that. And for the people joining from the server or anywhere else, if you're just finding the stream, today's launch will be taking place. I believe it's the closest to the equator as well, so it's from the Guyana Space Center in French Guiana, France. Today it will be launching east, and it will have a little boost since it's launching quite close to the equator, which means it gets a little kick versus when you launch from launch sites like North America or Europe. This technically also counts as Europe, but it's South America by technicality. It's not like on the actual European section. It is a part, though, of France. So it's basically Europe. Now we're currently 4 minutes and 35 seconds off until the launch. Currently everything is looking good so far. And we do have the mission control channels open, but it seems like we're not going to hear that. So that is quite sad. There's the timeline. We have the timeline on the screen. You cannot really see it since it's coverage, official coverage from international rocket launches. So it's not really the best, but for us when using it.
À tous de DDO. Attention pour la séquence finale lanceur.
We're hearing
À 0 moins
something.
5 minutes.
I believe that's the 5 minute. Yep, that's the 5 minute mark. That was a cool transition though. Just waiting for them to update the countdown so we can update ours. Apologies for that. Currently, everything is looking good so far. You can see there's the countdown. And there you can see the engine. This is from the core stage. Now, what will happen today, or in 4 minutes time, we will have engine ignition at T-minus 7 seconds, followed by SRB ignition at T-minus 0, following by liftoff. And this all will occur very quickly, so you gotta pay attention. There's the Ariane 6 launch center, and we currently are experiencing some lag. Apologies for that. Once again, footage from international rocket launches, and we're using them for today. And we currently want to thank as well everyone for joining us today on the stream. Currently have 10 viewers. Welcome everyone in, and welcome Sneaky Drummer as well. Welcome. Thank you for joining us today. T-minus 3 minutes, 20 seconds. Once again, those are the control centers that are operating for today's launch. And from what I can tell, looking pretty good. You can see the rocket in the back. $250. Huh? 240. We're coming up to the final minutes before launch. There you see that Ariane 6 rocket on your screen as we are go for liftoff in about 2 minutes and 20 seconds time. Now, about today's launch time, it is scheduled for 8:10 p.m. UTC, which could also be said as 5:10 p.m. UTC or local time. Sorry, it should be 5:10 p.m. local time, if I'm not mistaken. Or actually, I think there's a new launch time. Yeah, 5:11. That did lax a lot out. We're just gonna revert that back. Sorry for the lag you're experiencing today. We're trying our best here. We're streaming somewhere else. It's gonna be a little harder than usual. And you should hear me better as well now. So yeah. 1 minute, 30 seconds. Once again, should we hear me better now? Higher quality, as we're coming up to the final minute before launch. There you see that mission control here. And there's that launch director.
À tous de DDO. Attention pour moins 1 minute.
Here we go, that 1 minute call.
Top. H0 moins 1 minute.
T-minus 1 minute and counting. Ariane 6 is a minute away from its launch, carrying MTG-I2 into a geostationary transfer orbit. And there's the audience. Is it just me, or does part of you sometimes want rockets to explode just for something cool to happen? I mean, if it's boring launches, maybe I have that thought. Maybe. I do. Alright, less than 30 seconds away here. We're going to listen in as Ariane 6 will be launching. MTG-I2.
À tous de DDO. Attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage des ESR et décollage. La propulsion est nominale.
And there's successful liftoff of Ariane 6 carrying the MTG-I2 weather satellite to geostationary transport.
La propulsion est nominale.
Propulsion is nominal. See a good liftoff. T plus 35 seconds.
Le pilotage est calme. Tous les paramètres à bord sont nominaux.
minute into the flight. Everything is going as expected here. What's the blur thing at the bottom right? Yeah, we're just doing some editing here, live editing. Don't mind it, please. We'll get that solved. That's just what we're seeing here, so apologies for that. Now we should see at T plus 2 minutes and 15 seconds
Tous les paramètres à bord sont nominaux.
the SRB separation. Also, how many launches till I learn to count in French? Well, I mean, that's for you to decide. I've watched many French launches. I can count down in any Chinese, French, whatever language. Alright, it's a bit shaky camera. We'll see what they show on the feed. Yeah, it's still delayed,
Début de queue de poussée.
which is quite unfortunate. Alright, so please stand by. The SRBs have separated, but we are trying our best to get the feeds for you. There, we should have it on time now. There it is. SRB separation has occurred.
Séparation des ESR.
And there we heard the confirmation. Now, in about a minute here, we should have the fairing separate. Now, the stage 1, the core stage, will run for a couple of minutes until T plus 7 minutes and 43 seconds. So that runs for quite a long time. But that's nothing to compete to stage 2, which ignites at T plus 7 minutes and 58 seconds and burns until T plus 21 minutes and 48 seconds, which is a heck of a lot. And there we are currently seeing an animation.
Les paramètres à bord sont nominaux.
Everything is currently still nominal. We're looking at an animation here. We should have that fairing separate in about 15 seconds time.
Pilotage calme.
And there's that fairing separation.
Séparation de la coiffe.
And there's the confirmation. So the fairing is no longer needed. It's the protective shield from the rocket, and that is now no longer needed. We're continuing on course.
La propulsion est nominale.
Propulsion continues to be nominal. Now we are going to take a little break here from commentary. We'll leave the commentary channel or the mission control channel open, and we will be back in a couple of moments. Not before, though, we answer Sneaky Drummer's question, saying, how do launch trackers give launches in advance? Is it something with the FAA, and how far ahead can they be predicted? Either it's publicly announced or NOTAMs are available, and you have some smart people. Seeing this makes me wonder why the Artemis VFX looks so ugly. Yeah, I don't know. They're so much better in terms of that. Anyway, we're going to be right back with commentary here in just a few moments as we see Stage 1 shutdown.
Tous les paramètres à bord sont nominaux. Pilotage calme. Tous les paramètres à bord sont nominaux. La propulsion est nominale. Pilotage calme. Tous les paramètres à bord sont nominaux. La propulsion est nominale. Fin du mode barbecue. Tous les paramètres à bord sont nominaux. Extinction Vulcain. Séparation LLPM. Acquisition par la station natale. Premier allumage Vinci.
I did miss a few stuff as it happened
La
here.
propulsion est nominale.
Propulsion is still nominal as the stage 1 shut it down, separated, and stage 2 ignited.
Début du mode barbecue.
Now this is going to take a while, so we're probably just going to leave commentary over to the official broadcasters, and we'll be back once payload separates at T plus 30 minutes, 34 minutes, 36 minutes, whatever. And yeah, I don't think I'll stick around that long, but I think I need to stop commentary here soon as well, so we're just gonna do that. So I do want to thank everyone here for watching. Now, once again, when you're hearing this, we're not going to end the stream. I'm just going to stop commentating here personally. We're going to let the official Ariane Space broadcasters do their thing, so I can also talk on my own, and I probably have to stop talking here in just a few moments. So anyway, yeah, it was nice commentating, but we're going to leave it over to the official broadcaster. Thank you guys so much.
This was discovered by a genius, an astronomer called Johannes Kepler, 18th century, and it means that when you turn that into an altitude at which the spacecraft speed actually perfectly of the Earth, and this way, on this very orbit, the spacecraft somehow the same region of the Earth, following it. This is very day for meteorological measurements or predictions.
It's incredibly defined how orbits work. But then, about 3 centuries later, the science fiction writer Arthur C. Clarke imagined a modern use for that, because in 1945, he suggested that a satellite in an equatorial orbit nearly 36,000 kilometers above Earth would appear motionless in the sky and could act as a global communications relay. I think a lot of people thought it was rather far-fetched. But actually, he was right all along, and of course, together, Kepler's physics and Clarke's imagination have given us the geostationary satellites that we rely on today. So quite something. 10 minutes and 47 seconds into our flight. On the left-hand side of your screen are the main events as they are planned to occur. You can see the next one will be the end of the Vinci upper stage burn. So the tracking stations along our flight path along the equator are collecting the information from the rocket as it flies over, and they then transfer that, they relay it to the teams here at what we call the CVI, or the Quick Look Telemetry team.
Yeah, you can see them on the screen here. They are collecting currently the real-time data which the launcher sends to these different ground tracking stations. It includes many data, but typically the status of the engine, the trajectory, the flight control, and they are comparing live these data that the rocket sends to what was predicted. This allows them to continuously analyze the launcher behavior and confirm that this is as expected. And of course, they can confirm at the end that the separation is separated. I mean, is confirmed as planned.
They have an internal comms loop, don't they?
Yeah, to the range operations manager, who then confirms the key steps and share it with all of us.
Pilotage calme.
Doing a very important job there, and lots and lots of information all coming in very quickly, so they have to really concentrate hard. So there we have our satellite, MTG-I2, attached, hurtling through space. And satellites are vital for monitoring the climate and forecasting the weather because, well, I guess it's fairly obvious, but from space you can see things and detect things that you cannot see or detect from Earth. And they send regular data day after day over long periods of time. And that helps scientists to understand the bigger picture, but also to focus in on the details, so that's very important. Now, Meteosat third-generation satellites are a highly innovative system for Europe and Africa, and they are the latest chapter in a long partnership between EUMETSAT, the organisation in charge of managing Europe's weather satellites, and the European Space Agency. The full MTG system is made of 6 satellites. 4 of those are imagers, and 2 of those are sounders, and if you want to know more about what that means, then you're in the right place. Now is Graham Mason. Graham is the meteorological European Space Agency, and Graham, thank you very, very much to have a chat with us.
Thank you
Graham,
for having me.
Let's just start. To so important.
Well, and MTG-S1, which are already in orbit. MTG-I2 completes the in-orbit of the Meteosat third-generation satellites. The 2 imagers images on 6 with 500 meters resolution or 1 kilometer, depending on the channel, while the sounder has about 17,000 channels and allows to provide vertical profiles of the atmosphere, temperature, humidity, and so on. But this much.
Just going to just interrupt you there to say that we have acquisition at the next tracking station, so that's good to hear. Yes.
With the 2 imager satellites, it allows the 2 imagers to do different tasks. So MTG-I1 will do a full image of the whole Earth disk, which takes, for the high resolution in channels, that is about 500 million pixels.
Wow, that's a lot of pixels.
And it does that in 10 minutes. Mm-hmm. Whereas the I2 satellite will then focus on Europe, and it will do a repeat of the European area, including the Mediterranean and North Africa, every 2.5 minutes. So that will allow to track fast evolving weather situations.
And it's got some clever instruments on board, hasn't it, to do just that?
Yes, the first instrument is the flexible combined imager. That's a visible and infrared imager, and it's the world-leading geostationary imager, so beating the others in terms of performances. It is 16 spectral bands, and for it. The other instrument we have is the Lightning Imager, sophisticated instrument with 4 optical heads that continuously monitor about 80% of the, or more than 80% of the Earth's disk in a very narrow spectral band at 777 nanometers, which is where an oxygen triplet emits particularly enlightening.
So I'm going to say that's the technical stuff. How does this actually help us to really understand what's going on, particularly at the moment we're having a lot of very extreme events? How is this going to help us?
Well, as I said, the flexible combined imager and MTG-I2, it will provide rapid scans over Europe every 2.5 minutes. And that will allow to monitor these things. So just to give some examples, the infrared channels there can be used to monitor wildfires. And with an update of every 2.5 minutes of how those are evolving, that's incredibly important for tackling those and resolving the damage. The other issue, of course, is with rapidly evolving extreme weather systems. The imagers can show all that, and by combining the lightning imagery together with that can really help in identifying these rapidly moving, evolving systems before they get to extreme weather events.
Well, that's very, very important, isn't it? Very important for the emergency services as well to try and work out which way things are going and then plan and predict. So, I mean, this has been a huge collaboration of teamwork, hasn't it, Graham? Lots of different people working together to make this happen.
Yes, first of all, I have to say, I think the MTG satellites have already proven to be world-leading in terms of performances. The first MTG imager took 12 years to design, develop and build. And the second one has taken a further 4 years. So these have been done by many teams across Europe. The lead contractor has been Thales Alenia Space, but it's been a consortium of over 70 companies across 18 different countries, 200 subcontracts with over 2,000 people working on this at the peak. And I have to say that developing such complex satellites has only been possible through the professionalism, dedication and fantastic teamwork between all the teams involved.
Indeed. Graham, thank you very, very much indeed for coming to talk to us about. You are absolutely right. Let's go over now to Thales Alenia Space and to Olivier Brise, who is the program manager at Thales Alenia Space for our satellite, MTG-I2. They have huge expertise in this field, and I think he's absolutely the right person to hear about it from.
C'est un excellent métier puisqu'en fait on est un peu comme un chef d'orchestre par rapport à une équipe qui est à gérer, à manager, à être à l'écoute surtout, à jouer une partition mais qui est connue en théorie. Dans la pratique, il y a un gros écart. La grande difficulté en tant que chef de projet, c'est de maintenir leur confiance et de maintenir leur motivation. Malgré un environnement compliqué, on est constamment en train de s'adapter et on a besoin d'une très grande flexibilité. Le projet comme Météosat, c'est un vrai marathon. Moi, j'en ai déjà fait 14. Je dirais même que c'est une succession de marathons. À chaque fois, il y a un marathon pour l'aspect marathon pour l'intégration. On a besoin vraiment beaucoup d'endurance, de rester motivé. Aventure, grande aventure personnelle et puis grande aventure pour les équipes. Fierté, beaucoup de fierté par rapport aux résultats tels qu'on l'a obtenu. Beaucoup de respect par rapport à tout le travail qui a été fait. Les gens qui ont précédé cette aventure, beaucoup de respect pour eux. Et puis aussi, en avance de phase, beaucoup de respect pour les gens qui prendront le relais. Maintenant, c'est un gros bébé de 1,8 tonne. Une fois qu'il sera rempli, il aura une masse totale au lancement prête à 3,8 tonnes. Sa consommation n'est que de 2 kW, c'est même pas un four à micro-ondes. On lui a installé une batterie, il a 4 calculateurs à bord. Il va avoir une durée de vie de plus de 10 ans pour fournir toutes les 2 minutes 30 des images à l'ensemble des météorologues. C'est un bébé qui fait à peu près 7 mètres de haut, 2,20 mètres de large. Ça fait beaucoup d'émotion parce que c'est la dernière fois qu'on le voit et c'est quelque chose, quoi.
Oh, it's really moving seeing the emotion on his face there, seeing his satellite finally being enclosed.
Yeah, very, very touching indeed, yeah.
So during that film, we were picking up the signal at the next tracking station. That's Libreville, which is on the west coast of Africa. So it's only taken us 20 minutes to cross the Atlantic.
It's fast.
What's happening in space?
So we are still, sorry for that. We are still burning the upper stage Vinci engine. So we are getting close to the end of this burn, and this is a very key moment of the mission.
So that's coming up. The next moment, the switching off of the engine, and you can see there. Recap on the right-hand side. He's telling us everything's going well. We are at an altitude of 204 kilometers. And we're going to be climbing up to just under 3,000 kilometers. So you can see we're starting to make that climb up the hill there on the top right.
So just confirm the extension, so switch off of the Vinci upper stage engine. So it means that's a very important milestone. It means we have reached the target orbit today, and that all the previous steps we went through, so the boosters, the main stage, etc., were built to bring us here. So this is really important. And coming is the next steps. So there will be different maneuvers to orient the launcher and to do so to meet the requirements that were expressed to separate then MTG-I2 in the right direction.
Indeed. And Europe's Weather and Climate Satellite Agency, EUMETSAT, doesn't just fly the satellites, they also process the data that our satellite's going to be sending down. They deliver the real-time information that meteorologists use to make forecasts accurate and keep people safe. So that's very important, of course, and even more so now than ever before. We all use the daily forecast, of course, to plan our activities and our barbecues. But this summer's heat waves and wildfires show exactly why the data from EUMETSAT's fleet becomes even more crucial. They help meteorologists issue earlier warnings, which in turn, of course, helps the emergency services on the ground, as well as giving climate scientists evidence to understand how events like this are becoming even more frequent. Joining me now is Christian Bank from EUMETSAT. Christian is EUMETSAT's Program Preparation and Development Team. You head that team, Christian. Thank you so much again for coming out of the fishbowl, coming up here to chat with us. Christian, it's a very important satellite, isn't it? And understanding how the weather and climate are changing are very important. MTG-I2 are going to help us with that.
Absolutely. We're very happy that we can now complete the MTG family with this third satellite, 2 already flying, as Graham just before me mentioned. And the complement of these 3 satellites will provide us with all the necessary information that we can use, on the one hand, to monitor shortly, also in the long run, the climate evolution.
And what's so special about this particular
satellite adds one very important capability to the whole set. In 22 provides a global coverage every this particular set is every 2.5 minutes off Europe and the Mediterranean, so that we can monitor actually the evolution extreme weather conditions like thunderstorms or even
Yes, as we were hearing just now, which is hugely important, isn't it? I mean, we've seen that this summer. It's been very horrendous. So once it joins the constellation, how is the full MTG constellation going to actually change things for us in terms of improving forecasts?
Well, first of all, we're shortening the time we get the updates of the weather images with the 2 imaging satellites. That is a bigger improvement over the previous generation. Then we increase the resolution. That helps to cover a wider area, especially to the north of Europe. We can now also cover Scandinavia and the Northern Atlantic, and these are very important regions which we can cover with these satellites. And the third satellite, the sounder, is providing now profiles of the atmosphere, of humidity, water vapor, temperatures, etc. So we actually have a full resolution of the atmospheric conditions. And that helps to improve weather forecasts, but also warnings for extreme weather conditions.
And you know, creating this level of advanced technology is very much a collaboration, isn't it? I mean, we're talking here about huge expertise across Europe, and at the end of the day, these are satellites and their hardware, but it's the people behind them that make them happen.
Absolutely, and it's very important to have a network of experts that can actually interpret the data and make good use of them. So on the one hand, we have very important scientific group at EUMETSAT, which provides such expertise to the weather services in our 30 member states. So the weather services collaborate very strongly with our scientific division. And on the other hand, we also support the so-called SAFs, the scientific application facilities, which are also based in the National Weather Services, which then develop very special products out of this data. So there's a huge community around this system that makes the best use in the exploitation of these data.
Well, today, or this year, I would say, is a very special year for EUMETSAT, isn't it? Because EUMETSAT actually is celebrating its 40th birthday. So for 40 years, for 4 nights that you use have been powering weather forecasts. And before we do, I want to thank you very much indeed, Christian, for coming and talking. Let's take a look at 40 years of EUMETSAT.
This is the story of how Europe developed Earth from space, monitor weather and climate, and help protect cities. In 1980, to create EUMETSAT, turning this vision into a long-term. From the very beginning, EUMETSAT draws on the Meteosat program from geostationary orbit. The organization grows. 3 in 1988, EUMETSAT strengthens its operational capability, its network of international partners. Following a US satellite failure, Meteosat 3 is repositioned. Proves critical in anticipating hurricanes such as Andrew. SAT's mission expands to include climate monitoring, recognizing to understand changes in the 1995 marks another takes over satellite operations from ESA. From its new headquarters on the clock, ensuring continuous coverage over Europe and Africa. A new phase begins. In 2002, Meteosat second generation enhanced. Then, in 2006, METOP-A, Europe's satellite, provides a global view of the atmosphere. Flying from pole to pole, it delivers detailed measurements of temperature, humidity, and atmospheric composition, feeding numerical weather prediction models and improving forecast accuracy days ahead. At the same time, EUMETSAT expands its role in supporting European programs through the operation of key Copernicus Sentinel missions, starting with Sentinel-3 and Sentinel-6 for ocean observation. EUMETSAT becomes a trusted global partner, fulfilling the vision of its founders. Today, a new generation is carrying this mission even further. Developed in partnership with the European Space Agency, Meteosat, third generation, launched from 2022 onwards, enhances observations from geostationary orbit with higher resolution and more frequent imagery, alongside real-time lightning detection. In 2025, MTG-S1 and Copernicus Sentinel-4 introduce new capabilities, including three-dimensional observations of the atmosphere and continuous air quality monitoring over Europe. Meanwhile, METOP's second generation A1, together with Copernicus Sentinel-5, strengthens global atmospheric monitoring from polar orbit. Carrying 6 cutting-edge missions, including next-generation infrared sounder, YASI-NG, it delivers more precise data on temperature, humidity, and atmospheric composition. Together, these missions form a unified system dedicated to improving weather forecasting and early warnings, monitoring climate change, and helping societies adapt to its impacts. 40 years ago, EUMETSAT was an idea. Today, it is a critical infrastructure for the planet. Because behind every satellite, there is a purpose. To warn earlier, to understand better, to act faster. And in a changing world, that makes all the difference. This is EUMETSAT. Trusted in space, essential on Earth.
Trusted in space indeed, and absolutely essential on Earth. And right now, the latest satellite to join the fleet is hurtling through space, attached to what's left of our rocket, the upper stage, heading towards its delivery orbit. And as we said, it's going to geostationary orbit. That's 36,000 kilometers above our planet. But actually, the rocket's not taking it all the way there. It's going to drop it off at just under 3,000 kilometers. We call that a geotransfer orbit. And the satellite will travel the rest of the way on its own.
Yeah, indeed. Yes, correct. In fact, the orbit on which we'll separate MTG-I2 is it looks like an ellipse. It's an oval-shaped orbit. Remember Kepler we talked about earlier? He was the one who discovered at the beginning of the 17th century, again, that the planet orbits were around the sun were actually ellipses. He's saying everything is fine. So it's just as our orbit today, that is also an ellipse.
So an ellipse, I mean, you could think of it, I mean, I know you said it's an oval, but I guess you could think of it as the shape of an egg, with the yolk, the yellow part, inside the oval at one end, and then what the sort of the egg shape is the far end of the oval. And
the yolk would be the Earth.
The Earth, of course,
and
yes.
our spacecraft orbiting the Earth on that oval shape. And this oval shape has a closest point to the Earth, that is at 250 kilometers. And then the farthest point, of course, is the highest altitude we are targeting today, 36,000 kilometers. And today we'll separate MTG-I2 to an altitude just below 2,800 kilometers. And it, as you said, it will continue the journey up to 36,000. But I mean, thanks to the speed given by Ariane 6 with the previous steps we had, it will use then its own engine, the spacecraft engine, to circularize the orbit and stay at 36,000 kilometer altitude.
So it's clever stuff. Ahead, it's going to take it about 6 months to get to its final orbit up of different burns to get there, of course. So we're orientating ourselves, that confirmed there by the range operations manager. Whilst the early part of the launch was all about power and getting us away from the planet, and this part is all about precision and delicacy. And that's because we need to deliver the satellite onto a very specific orbit and in absolutely the right orientation. So right now, that's what's happening. The
it's not
getting
only
ready.
Exactly. It's not only getting to the right place, but also pointing the right direction. And this is the aim of all the maneuvers that we've been performing over the last minutes. So on the separation orbit here, before separating the spacecraft, the launcher is slowly doing orientation maneuver according to what the customer has expressed in terms of spacecraft orientation for separation. So this is done very smoothly. Because we want to master very precisely both the direction and the speed, because we'll have a very low spin rotation. So that's why we do it really step by step, to have it very well mastered.
And you can see actually that we are just very gently rotating at the moment.
Indeed.
To get the temperatures nice. recap there, right-hand side of your altitude. We're getting really close now, aren't we, Samuel, to our separation? At the moment, we're 2,585 kilometres. We're going to climb a little bit further. We're travelling an awful long way from the pad. And our speed 7 kilometers per second.
The light, in fact, will kind of unfasten its safety belt because we have what we call a clamp band to its
Extinction de l'APU.
Launcher, and so we'll unfasten the clamp band, and then that is used to gently push away the satellite in a very well mastered, safe distancing without collision, but of course the distance. And we've just confirmation of MTG-I.
We have separated us. That is great news. Faces there, Samuel, in the Mission Control Center.
Yeah.
Giving each other some hugs. He has worked very hard for this. There we can see some Thales Alenia space teams, and there's Olivier Brice, who we saw earlier, talking about his big baby.
Confirmation de la bonne séparation de MTG-I2.
Manager, that it is the correct separation.
Indeed, yeah. But that's really to all the teams that made this happen.
So, of course, now
Look at these hugs.
Lots of hugs. The team here, but for now flying the new baby, they are taking on the job. It's just the beginning. Xio is taking on what we call the launch and early. That's probably about the next 12 days or so. They satellite through its initial tests. But let's go back now into believe is yes, David. Hi there. It's all been looking really nice. We're looking at lots of very happy faces. Good.
Yeah, absolutely, Katie. This launch is a full success. Into the right orbit, and we are delighted.